Welcome to Seeing Beyond Reality, the AI Vision Revolution. In this episode, we explore how artificial intelligence is reshaping the way we perceive and interpret visual information. With 122 papers published in a single day, this journey covers the latest breakthroughs in AI-generated and AI-understood images, from synthetic realism to advanced detection. Prepare to discover how AI is transforming the very nature of what we see. This presentation charts the computer vision frontier by diving into 122 cutting-edge research papers released on August 5, 2025. The discussion unpacks dominant themes such as generative modeling, robust detection, and multimodal research. Transformative methodologies and technical advances are highlighted, with a special focus on 3 seminal papers that are actively shaping the direction of the field. Additionally, we will examine emerging challenges and provide a glimpse into the future of computer vision. Computer vision is the science of teaching machines to interpret the visual world. It enables computers to extract meaning from images, videos, and three-dimensional data, powering applications that range from smartphone cameras and medical diagnostics to autonomous vehicles and industrial robotics. Fueled by major advances in machine learning, especially deep neural networks, and the availability of large-scale datasets, computer vision is now central to progress in artificial intelligence, safety, and creative industries worldwide. Theme 1 centers on generative models, positioning AI as the new visual artist. These models can create images, videos, and animations entirely from scratch. Notable works include LongVie by Gao and colleagues, which enables controllable, ultra-long video generation, and CoEmoGen by Wang and collaborators, which crafts images designed to evoke targeted emotional responses. The underlying technical concept relies on diffusion models, which iteratively refine noise into coherent images. Recent advances allow for fine-grained control and unprecedented realism in AI-generated content. The second theme focuses on robust detection and recognition in challenging conditions. Detecting AI-generated or manipulated images is increasingly crucial as synthetic media proliferates. The RAVID framework, developed by Keita and colleagues, excels at spotting fake images, even after intentional degradations such as blurring or compression. DICAFnet, introduced by Li and team, enhances detection in cluttered and imbalanced scenes. Furthermore, these detection methods are now being applied beyond Earth, including crater identification on Mars and the Moon. Retrieval-augmented frameworks form the technical backbone, significantly boosting detection accuracy under adverse conditions. Cross-modal and multimodal learning represents the third major theme, enabling AI systems to bridge and blend diverse data types. For example, the Vela framework by Liu and colleagues generates panoramic 3D LiDAR scans from a single color photograph, democratizing access to 3D perception. In medical contexts, new models are linking imaging data with clinical notes to foster deeper insights. Cross-modal learning unlocks richer, more versatile AI applications, with vision language models, commonly referred to as VLMs, empowering capabilities such as image retrieval and automated captioning. The fourth theme examines advancements in vision for health, particularly in medical imaging and diagnostics. Vision models are now integral to precise and adaptive medical diagnoses. The policy to assist iteratively local segmentation framework guides radiologists through complex workflows, improving accuracy and efficiency. Optics-driven neural networks are advancing minimally invasive diagnostic techniques. Cross-pollination with general vision models enhances robustness, while increased emphasis on explainability and reliability ensures that these systems earn clinical trust and support critical decision-making. Key findings from this body of research indicate a new era for visual intelligence. Retrieval-augmented detection systems, such as RAVID, are setting new standards for media authenticity. Practical solutions for long-form, controllable video generation, exemplified by LongVie, are now attainable. Cross-modal synthesis, as demonstrated by Vela, is bridging the gap between two-dimensional and three-dimensional perception. Adaptive segmentation techniques are transforming medical imaging workflows. Central to all these advances are growing concerns and efforts around robustness, fairness, and explainability. Progress in computer vision is being driven by several core methodologies. Diffusion models and generative adversarial networks, or GANs, are foundational to recent generative breakthroughs. Vision language models and contrastive learning approaches enable sophisticated cross-modal tasks. Retrieval-augmented generation, often referred to as RAG, adds factual grounding by dynamically integrating external knowledge. Attention mechanisms and prompt engineering guide model focus toward the most relevant input features. Transfer learning and self-supervised learning reduce the dependency on extensive labeled datasets, streamlining development in data-scarce environments. The RAVID framework, or retrieval-augmented visual detection, is a seminal contribution by Kata and collaborators. Their approach introduces a knowledge-driven, retrieval-based detection system that excels at identifying AI-generated images, even when subjected to degradation such as blurring or compression. RAVID achieves a 93.85% accuracy rate on the Universal FIC Detect benchmark, which encompasses 19 different generative models. This marks a critical advance for media forensics, shifting the field from simplistic pixel-level analysis to sophisticated, context-aware detection. LongVie, titled Multimodal Guided Controllable Ultra-Long Video Generation, represents a breakthrough by Gao and team in generating coherent, high-resolution videos of significant length. The framework addresses persistent challenges by implementing unified noise initialization and integrating multimodal control mechanisms, ensuring visual consistency throughout the generated content. The introduction of LongVie provides a dedicated benchmark for evaluating long-form video synthesis. LongVie was selected for its ability to enable scalable and controllable content creation, opening new possibilities for entertainment, simulation, and beyond. VELA, or panoramic LiDAR generation from a monocular RGB image, is a pivotal paper by Liu and colleagues. This work bridges the gap between traditional two-dimensional photographs and three-dimensional LiDAR data using a conditional diffusion model. Key technical innovations include confidence-aware conditioning, which dynamically adjusts to local reliability, and geometric cross-modal alignment to ensure structural accuracy. VELA establishes new performance benchmarks on datasets such as new scenes, semantic kitty, and kitty weather. The framework is recognized for democratizing access to 3D perception and enhancing the real-world applicability of AI systems. Looking to the future, several promising directions are emerging for computer vision. Broader adoption of retrieval-augmented and knowledge-driven systems is anticipated, enhancing both generalization and interpretability. Efficient learning methodologies will support deployment on edge devices and in low-resource environments. Advances in cross-modal synthesis are expected to enable richer simulations and human-computer interactions. There will be a stronger emphasis on fairness, explainability, and uncertainty estimation. Balancing model power, robustness, and ethical responsibility remains an ongoing challenge as the field continues to mature. This presentation deck was created through a synthesis process powered by OpenAI's GPT-4.1, which supported narrative construction and insight extraction. Text-to-speech synthesis services from Amazon were used, while Google's image generation tools assisted in visual summarization. All content was reviewed by a human expert to ensure technical accuracy, however, some oversights may remain. For comprehensive understanding, listeners are encouraged to consult the cited references, as all paper details and sources are provided transparently. Thank you for joining the AI Frontiers community. Subscribe to our YouTube channel for the latest research breakdowns and stay updated with in-depth analyses and trends in artificial intelligence. Engage in the discussion and help shape the future of AI. Your insights and questions guide our explorations. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses R14.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by R14.org.